Good afternoon, everybody. Welcome to the 18th Annual Summer Student Research Symposium in virtual format this year for the first time. The symposium showcases the work of students in the Emerging Caribbean Scientists, or ECS program, which offers scholarships, summer programs, research experiences, mentoring, and supplemental instruction to UVI students majoring in science, technology, engineering, and mathematics, also known as STEM. Programs within the ECS program include maximizing access to research careers, historically Black colleges and universities undergraduate program, research initiative for scientific enhancement, summer undergraduate research experience, and summer sophomore research institute. The University of the Virgin Islands is also one of the 10 minority serving universities for cooperative agreement awards with NASA under the Minority University Research and Education Program. The Cybersecurity Fellowship Program at UVI has a goal to provide training and in the future increase the number of diversity of the nation's cybersecurity experts. So we have presentations at this symposium from all of these programs today. In addition to these programs, this year's summer research is supported by the National Science Foundation, College of Science and Math at UVI, and generous donations of private donors. The symposium, we have 6 sessions that are being run concurrently. So 6 sessions running next to each other at the same time. You can find the schedule in the abstract book at the UVI ECS website if you didn't receive it in your mail, in your email today. We will keep presentations on schedule to allow symposium attendees the opportunity to move between sessions and not miss anything. You can leave and enter any session as often as you like. Note that we will stick with the schedule, so if a student is missing the next presentation, we'll still start at the scheduled time for that presentation. So if you end up in a room and there's nothing going on, that might be what's going on. If you are unfamiliar with Zoom, take a moment to familiarize yourself with its features. We ask that you remain on mute throughout the presentations and put any questions you might have in the chat box. I will be monitoring the chat box to see if there are any questions or any comments, and I will bring those to the floor when the presentation has finished. Each presentation is a 5 to 7 minute speed talk, and there will be time for questions at the end, although the next speaker will start on time at the 10-minute mark. We have a few more minutes. We have 1 minute, I guess, before we will get started with our presentations. Does anybody have any questions or comments right now?
Realize that. First time her we're living with you, but she lived with her mom before that, correct? Okay, let me begin again. Okay, so there's probably a lot of resentment there from her. I mean, you're kind of basically, you know, like a stranger. Yeah, I guess I'll.
Okay, so we will start with our first speaker, Michaela Carino, comparing St. Croix East End beaches. Michaela?
Hello, good afternoon, everyone. As I said before, my name is Michaela Carino. My mentor was Caroline Pott, and my research is about comparing St. Croix Eastern beaches. Next. You can do it. Next.
More than just when you do the dishes and have your friends go home at a certain time.
I'm a little bit stuck right now with the changing of the slides. Just bear with me. There you go.
Okay, thanks. So the program we use was Sandwatch. It's a global educational program where we work together to monitor coastal environments and also identify and evaluate the problems. We focused on beach profiling, human use, beach composition, and sargassum. Sargassum was a separate experiment that contributed to our research. The four beaches that we focused on was Chenay Bay, Chenay Hole, Robbins Bay, and Cramer's Park. We had three hypotheses. Our first hypothesis was that south side beaches have a more gentle slope than the north side beaches. They also have a minimum human use and a larger accumulation of sargassum. Next. So this is where the beaches are located on Singroy from north to south. The south being Cramer's Park and Chenay Bay, and the south being Robbins Bay and Chenay Hole. Next. These are some of the equipments that were used to conduct this research. Next. So for beach profiling and beach mapping, we sketched important landmarks or later will be used as reference points. For beach profiling, we use an Benny level, which is at the top right, transect rod, and also a magnifying glass. We also use a profile analysis software to plug in those slopes. And these slopes can tell us when the beach has changed, can be done daily or yearly. Next. For human use, we observe what goes on the beach, the different activities that are taking part on the beach, and also how many people are doing those activities, and also the time that was spent on the beach. Next. For beach composition, we went to those reference points that was taken down earlier, and at each reference point, we took 3 samples of sand, and we used the sifters, which is units goes from 5 mm to 12 mm, which is millimeters, and as the unit goes up, the smaller the science grain would be. Next. For sargassum, we use a telescopic rod and a transect measuring tape to determine the depth and the width of the sargassum. Below shows a picture of how the sargassum looks like on Chenay Hole. And also another picture shows a satellite view of the sargassum floating in the currents passing the islands. Next. So our results. First, we'll look at the north side beaches. Next. Click, click, click. Okay, so there was not much of a difference between the reference point for the beach profiling, nor did they have any difference with sea composition, but the most difference was on human uses. So we'll be focusing more on the human use aspect for each beach. So Chenay Bay had a lot of people at the beaches. So below shows the different activities, which is the graph that is on the left, the top left, shows the different activities listed in the x-axis and how much people are doing those activities. Next. Oh, wait. The graph next to it shows the sand composition and the graph below shows the slope of the beach. Next. Click, click, click. So just like Chenay Bay, Cramer's Park had a good amount of people on the beach, and the time that was spent on the beach is at the top. Next. Now for the south side beaches, which is Chenay Hole and Robbins Bay, they absolutely had no human uses on the beaches, and we think that this is because of the sargassum that's on the beach because the sargassum is the smell is very pungent. So we expected that there will be nobody on the beach. Next. Like I say, for Robin Bay was the same. There was absolutely no human uses on the beach, on these beaches. So our sargassum results. So the 4 orange dots shows that's on the left graph shows the decrease in the depth of the sargassum, and the 4 blue dots shows that the Turner hole had an increase in width, but the Robin Bay had a decrease in the width. And this can be explained by the simultaneous decomposition and the new arrivals of sargassum that is shown on the right side. There's 2 graphs that shows on the right side. And it also shows that Turner Hole continued to receive a large amount of sargassum, but Robin Bay experienced decomposition and less new materials. Next. So our conclusion was, or discussion was that for beach profiling within the study period, there was no observable changes of each reference point, and our method did not allow us to answer the hypothesis about the overall beach slope. In accordance with my hypothesis for human activity, it was concentrated in the north side of St. Croix, and the measurements that was taken of the sargassum was repeatable and representative, but with limitations. And for future works, we're going to conduct more frequent observations for the testing of sargassum and also for the sand composition, because we didn't know what caused it. I apologize. We did not know what caused it and why it is happening. Next. These are my references. These are my acknowledgements. And thank you. Any questions?
Great job. Do we have any questions for our speaker today?
Any questions?
Come
on, lay it all on me.
I see a comment from Kristen Wilson Graham saying, "Good job, Michaela."
Thank you very much. Your talking experience, but thank you.
Any other questions?
Right.
Okay, thank you, Michaela. Our next speaker is Tion Grant, who's going to tell us about Lindbergh Bay.
Good afternoon, everyone. My name is Tion Grant, and my research is under the topic is Lindbergh Bay eroding since the airport expansion on St. Thomas. Next slide. So just a little history. Before Lindbergh Bay got its name, it was originally called Mosquito Bay, and this name was changed during the construction of the airport in the 1920s. So in 1992, there was an expansion of the airport as we know it now. And in order to get the materials for this expansion, they had to dredge the bay, and there's a significant hole that is there up to this day. Next slide. So many individuals that have been studying Lindbergh Bay have the notion that because of this dredging project, the beach has been eroding, and we want to look at whether this is true. Is that, well, whether there's an increase in the erosion in the beach due to this hole. Next slide. So the research goal for my project is to use wave propagation analysis to determine whether the hole that is there is an actual factor in the erosion that's occurring on the beach. And just to give you some information on waves, waves are a medium for energy transport, and they're created when there's a disturbance in the liquid that causes the water's equilibrium to rise above its line and During this process, gravity would push back down on it, creating the spring action that we know. And waves are essential when it comes to forming a beach because they move sediment on and off the beachfront. Next slide. So my methodology, I first modeled Limburg Bay using one-dimensional modeling tools. So I used the MATLAB modeling tool. So that is a screenshot of my script that I wrote and was edited by my mentor. And then I developed a script along with that modeled the wave evolution and erosion potential equations. So two equations I have there. The first one, wave evolution, which is equal to wave generation by wind minus wave breaking, bottom friction, so the friction as the wave passes over the seabed, and wave dissipation due to vegetation. So specifically for our project, we negated the effects of bottom friction and vegetation. So it was only focused on wave generation minus wave breaking, so that you could have an understanding of how the waves really affect the beachfront. Now, when we look at the sand erosion potential, that equation is a ratio of the destructive force of waves, U off, over the constructive force of the wave, UB. Next slide. So our results. In the bottom profile, we see that this is a model of the seafloor on Limburg Bay, starting from 10 meters below sea level. So the blue line represents the hole that is currently there, and the red line represents an interpolation, so a theoretical new seafloor that we created for comparisons. In the top graph, we see that it looks at the wave height, so how the wave interacts with the seafloor and the height that occurs because of the wave passing. So from 10 meters below sea level to about 6, we see that it's the same because the seafloor has not changed, so it will follow the same wave height. There's only a change during the beginning of the hole to the end where the wave height is lower because of a drop in the depth of the seafloor. And the interesting part is at the end, right after 40 meters past the original point, the initial starting point of the wave, we see that the wave height increases increases when it leaves the hole compared to when we fill it up. So that shows a significant amount of energy that the wave has, and this energy is what will be splashing onto the beaches. Next slide. So this slide looks at wave power, the equation that I showed you before, versus the erosion potential. So the orange represents when we fill the hole using our interpolated seafloor, and blue represents when the hole is there. We see that when we are dealing with small levels of wave power, so when we're dealing with the small amounts, we see there's not much significance in how much erosion is occurring. However, as you increase the amount of wave power, we see that the erosion potential increases drastically until when you look at a wave power of roughly 375, we see that our erosion potential is way lower when you fill the hole compared to when the hole is present. So next slide. So at the end, we're able to conclude that with smaller waves, there is a similar erosion potential over both seafloors. The breaking wave height when it comes to larger waves increases much more with the hole compared to without it. And as the wave power increases, we see a significant increase in the amount of erosion potential compared with the hole present, especially when we're dealing with much more powerful waves. Next slide. So for future work, we wish to look at the Limburg Bay profiles from a two-dimensional standpoint. And in order to do that, we'll be implementing SWAN data modeling. So this tool is used specifically for looking at it from a two-dimensional standpoint. And we also wish to compare the erosion with increasing water levels. So this is in the topic of climate change. So we know that it has been shown that the water levels will continue to rise, and we want to see whether there is an increase in the erosion potential due to this increase in water levels, or if there is not. Next slide. These are my acknowledgements, and special thanks to my mentor, Dr. Greg Wanell. And thank you for listening. Any questions?
We have time for a few questions or comments. So Tian, then I have a question. Should the hole be filled?
Yes. So according to the analysis that we ran, and this analysis was over as you saw, many different wave heights and wave power calculations.
Mhm.
It needs to be filled, because like when you're dealing with the regular waves that we see every day when we go to the beach, it's going to be the same erosion potential, but you have to consider the fact that we are in the Caribbean and we have situations like hurricanes, as we see, and tropical storms that are coming. And with that increase in the wave power, there will indeed be a much higher erosion potential due to the amount of power coming from these waves. So filling the hole is indeed the best option.
And what should we fill the hole with?
Well,
And are there any challenges or issues with filling the hole?
I personally did not look into that, but if I can give my personal opinion,
Yes.
we we took out sand out of the hole, so filling it back up will not be a bad idea with the same material that was in there originally. Because with the information I learned from just looking at waves, is all waves are doing is moving sediment back and forth. So if you fill the hole back up with the same materials that was presently in it, the top layer of that material will just be moving back and forth. And as we see when we interpolate it and it shows like our theoretical seafloor, it's much better than having nothing in the hole at all.
Okay. So just a thought, because I don't know that we have time to explore this, but a number of years ago, there was some suggestion that we fill that hole with dredge spoil that comes out of the harbor. Just very quickly, yes or no on that?
So just to clarify, so they want to dredge the harbor and fill up Lindbergh Bay.
They want to dredge the harbor to allow cruise ships to come in, deeper cruise ships to come in.
Okay.
And they didn't know what to do with the dredge spoil, so they proposed putting it in Lindbergh Bay.
Well, considering that it's already sediment from the seafloor, so I guess if the material is the same and there's not much difference in the type of material being dredged up from that area, that would be the best option to do with it.
Okay, great. Thank you. We're going to move forward. Thank you very much. Tian, our next speaker, let's see if I can get this to go forward. Apparently not. Is Adina Brown.
Good day, everyone. My name is Adina Brown, and today we'll be focusing on rays and ecotourism. What is ecotourism? Ecotourism is a direct towards exotic and often threatened natural environments intended to support the conservation efforts of unobserved wildlife. So what are stingrays? Stingrays are a diverse group of fish. They're characterized by their flattened bodies. They're mostly found in tropical and subtropical areas. They're usually in warm and shallow waters, and they're mostly found hidden on the ocean floor. Next slide. The article focused today is supplemental feeding for ecotourism reserve activities and alter movement patterns, spatial distribution of the southern stingray, Diestes americana. My question was, does anthropogenic factor have an effect on the behavior of stingrays? Next slide. Okay, the method they went about doing this at Grand Cayman Island was 2 groups of stingrays were tracked, which they categorized it in fed and wild stingrays. They used this using a handheld GPS. A transponder was tagged onto each stingrays. Fed were sampled monthly and wild were sampled weekly. They measured the disc size and sex for each fed and wild stingrays. Next slide. To your left, you could see tourists feeding the stingrays. This is at Grand Cayman Island. You could see them going around looking to be fed. And to your right, this is the study site, where highlighted in red are the study areas, which is to the bottom of Grand Cayman is South Sound, and then above is Rum Point. And then close to Rum Point is Stingray City Sandbar. Next slide. Okay, so they did 2 types of measurement, manual and automated telemetry. So telemetry is basically the collection of measurement or data at a remote point. So for manual telemetry, the maturity was assessed directly for males using their claspers classification, which is the reproductive part of a male, and for female, the size of their body. This was tracked using a boat. 2 persons were aboard this boat, a tracker/diver and an assistant. This was manually for 11 to 72 hours, and for every 10 minutes, they record their position. Next slide. For automated telemetry is the opposite. Instead of manually doing it, they insert a transmitter into the stingray's body. And they had a receiver A and receiver B. For data analysis, they used a Mann-Whitney U-test and a Crosco-Wallace test. For the Mann-Whitney U-test, this was used to measure the activity spaces of the stingrays. And as you can see, the p-value is less than 0.01, which means there is a significance between activity space of wild and fed stingrays. It is said that fed stingrays have a smaller activity space. For the Crosco-Wallace test, this was used to measure rate of movement, and it had no significance since the p-value is greater than 0.05. Next slide for me, please. Figure 3 is a comparative activity space size of fed and wild female stingrays. The white bars are representing fed stingrays, and the gray ones are representing wild stingrays. And as you can see, compared to daytime, nighttime, and 24-hour active spaces, wild stingrays are greatly higher. For figure 4, this is the overlap, which A represents the Stingray City sandbar. This is Stingray City, and you can see that there's a lot of overlapping with the stingrays being present there. And B representing the South Sound, which you can see there's no overlap at all. Next slide. For figure 5, this is a comparative of daytime and nighttime at Stingray City. As you can see, panel A is daytime, and you could see that they're more active during daytime and less active during nighttime. So kernel contour is a measurement of density for a location at intersections. So you could see that I don't know if you could see it because I have glasses and I can't see too greatly as well. The line gray is tracking their movement path, so where they travel back and forth to. Figure 7 is the South Sound control site. And you could see compared to the Stingray City and the control site, you could see there's a bigger area in the wild stingrays rather than the stingrays being fed. Next slide. To conclude, it said that feeding stingrays can have cascading effect on prey and predator impact. So it can impact the stingrays, how they feed, because they usually feed during the nighttime and they're more active during the nighttime, and they could also affect predators and prey. Usually stingrays go under the seafloor, and sometimes it brings up prey for other predators. Sometimes barjacks use stingray as covers from predators. Next slide. This is my literary cited. And any questions?
Okay, we have a couple of minutes for questions. Any questions from the audience? Adina, I have a question. On one of your slides, you showed that there was something about wild stingrays are higher, and I wasn't sure. Let me see if I can go back to that slide. I wasn't quite sure what you meant by that. Oops. There we go. So this slide, figure 3. The white ones are the fed ones and the gray ones are the non-fed ones. What is that? What is a kernel contour?
So as I explained, a kernel contour is a measurement of density.
Density of what?
The density of movement, like, how can I explain it? It's like the area the stingrays travel
Oh, okay.
from like one position to the next position, from
Okay.
one point to the next point.
Okay. So then just generalize this. What is this graph showing us?
So it's showing you that for daytime activity space, the fed stingrays were less active than the wild stingrays. The wild stingrays were more active.
Oh, okay.
And then
okay.
for the nighttime.
Okay, that makes sense. Should feeding of stingrays be discontinued, or are the benefits of ecotourism outweighing any of the negatives?
I don't think it should be discontinued. We should just manage it wisely, see how we could try to incorporate more of their feeding habits regarding, like, I know like tourists might not want to go into the ocean at night, more daytime, you could see more. But like, for instance, what they're feeding them is not really what they eat, like squid. So like incorporating what they eat probably could help as well.
Okay, great, thank you. I have to move on. I'm going to stop sharing that, and I'm going to go, hopefully, let me see. Oops. Our next speaker is Sarah Hutchinson, and she's going to talk about frogs in a video. Hope we can get this to work. Oops. Okay, can everybody see the screen? Okay. Can everybody hear this?
No, Renata, you need
Not
to
at all.
computer
Okay.
as well.
Yep.
Neil.
It might be under options in the share.
Oh dear. Sorry. I am not. There we go. Okay. We're gonna try this again.
Kaleidoscope.
Okay, this should be better.
My research question is, can we use machine learning to identify frog calls? And my hypothesis is that there is no difference between manual identification and the classifier generated from Kaleidoscope. So what is Kaleidoscope? Kaleidoscope is an acoustic analysis software that uses sophisticated pattern recognition software
Sorry.
to automatically scan large quantities of audio files, detecting similar vocalizations and quickly sorting them into groups of similar sounds called clusters. Here's an example of what my Kaleidoscope software looked like. It uses something called the principal component analysis, which is a dimensionality reduction method that is often used to reduce the dimensionality of large data sets by transforming a large set of variables into a smaller one, which contains most of the information in the large set. Smaller data sets are easier to explore and visualize and make analyzing data much easier and faster for machine learning algorithms without having many variables to process. To sum it all up, PCA is simple. It reduces the number of variables of a data set while preserving as much information as possible. So we take this set of bird sounds and Kaleidoscope would cluster these vocalizations and turn them into groups of these different species of birds. My methods were to obtain the recordings from the Great VI Frog Count Citizen Science Project, and then I would cluster my vocalizations using Kaleidoscope from a reference set of recordings according to the similarity of sound pattern, frequency, which is frequency range, duration, and the acoustic shape of the vocalization. I then manually ID'd a few of my acoustic signals of interest, and this would be used as the training. This would be the training that my machine would get. And then I refine my clusters 2 times. So I took my initial set of recordings and I reran them on this edited cluster that I got, and then I compared my auto ID output with my reference data, which is the spreadsheet that contains the confirmed presence or absence of my 4 species of frogs that I'll be using in my research. So here I'll be showing you the frogs that I used, as well as a sonogram of how the frog sound looked, the vocalization. I'll play sound of a red-eyed coqui. I have a whistling coqui. that sounds like this. We have a white-lipped frog. Sounds like this. And a Puerto Rican coqui. This brings me to my results. So on my left, it has a comparative bar chart between the present and detected frog species in the acoustic recordings. So the present species are those that are found in my reference spreadsheet, and the detected were the ones that were generated by my classifier. So this shows that there was a large number of false positives that were seen across all 4 species of my frogs. And then this would lead to an overestimation of the presence or absence of frogs in my different recordings at different places. And so on my right, I have a comparison of my precision and accuracy of my 4 frog species. So precision is how close my results are to each other, while accuracy is how close a measurement that I have is to a known or accepted value. My accuracy would be in relation to my reference spreadsheet. And so it's showing that my answer lenses had a higher precision than the other 3 species of frogs and had an equal amount and approximately same accuracy. While for the Lepta albilabrus, it had a very low precision but a little higher accuracy than there was for the answer lenses. And so I performed a chi-square statistical analysis, and my p-value turned out to be less than 0.00001, and this result is significant at p being less than 0.5. And this means that there was a difference in my classifier generated by Kaleidoscope and the reference set of data. And this shows that my classifier did not perform as well as I would have liked it to. That my hypothesis is then rejected because there is a difference between my classifier generated by Kaleidoscope and my manual identification or my reference to the data. And it's showing that my classifier that was generated for E-answer lenses was equally accurate and precise, but for albilabrus, it had the highest accuracy of the 4. My future work then is to revise and refine my cluster and in hopes of improving my accuracy and precision. And then I would be able to answer what the differences are in species distribution and assemblies across elevational and east-west gradients, different levels of urbanization, and invasive species presence or absence. I would like to acknowledge that this project was made possible by the ECS Honors Fund and my mentor, Dr. Renata Plattenberg. Thank you for listening. Have a great day. Are there any questions?
Okay, any questions? Okay, we are going to move on to our next speaker. Oh. Our next speaker is Nikai George.
Okay, good afternoon. Hi, George. My mentors are Drs. Bryce Orange and Marshall Parsons. Welcome to my presentation, Design and Manufacturing of Low-Cost Hardware to Benefit Precipitation Monitoring. Next slide. The University of the Virgin Islands Etement Observatory is home to several innovative technologies, such as the Virgin Islands Robotic Telescope, (VIRT). For this project, we increased the technology readiness of a long-range radio communicator that detects precipitation. The purpose of this device is to monitor incoming rain and communicate any detection back to the observatory, so the telescope will close and be protected. Our project built upon the first generation design, improved the interface between components and external entities, and detailed the power budget to optimize solar power requirements. We hypothesize a good design for this device should be functional, durable, sustainable, expandable, and aesthetically pleasing. Next slide. This is the second generation of our device. Each external entity on the box is able to function without interference from each other. The device is also compact enough to be placed on a pole or wall and not take a lot of space. Each component is effectively placed within, which allows for extra space that can be used to expand the device's capabilities. The device is composed of store-bought items and 3D printed parts. Next slide. For this device, we are 3D printing the mounts for the rain sensor, solar panel, and wall or pole. We'll be using a Form 2 SLA 3D printer. As you may know, resin is a substance that hardens and becomes a polymer. 3D ink to simplify. We'll be using a resin named Tough 2000. It is both durable and temperature resistant. This is one of the best materials to use for our device because it will need to survive outdoors for long periods of time. This material will handle our tropical climate perfectly, protecting the device for years to come. Next slide. The store-bought items needed to be both accessible and affordable because this device will be created multiple times. The prioritized components include the LoRa radio transceiver, weatherproof box, solar panel, RG11 rain sensor, battery, and antennas. The estimated cost for all items is between $50 to $100. Next slide. In the first generation, a 1.5 solar panel was used. It could barely store and supply the device with power. I created various simulations to figure out the right solar panel we will use. We then settled on using a solar panel that generates 10 watts of power. This is a surplus amount to self-sustain the device for days with the assumption of bad weather and power drain factors. We also decided to use a point-to-point wireless communication. PTMP is the ideal option because it allows for multiple scattered stations communicating to a base station. PTMP is in collaboration with a technique called polling. It's like a traffic light for communication transfer. Multiple stations wait for their turn to relay information to and from the base station. This device is operating on a frequency of 915 megahertz and has 8 miles of range. Next slide. There were many methods that went into the construction of the device. Modeling and sketching were used in conjunction for the design, structure, and functionality of the device. Simulating with graphs helped to visualize and predict how the device will operate in the real world. Programming was primarily used for the rain sensor to lay out its tasks. Next slide. Configuring the second generation of a LoRa rain sensor came with many challenges and setbacks. However, we were able to overcome them to prove our hypothesis. This low-cost, self-sustaining device will be able to function and stay intact, all while being able to expand. We can take the device further by increasing communication range. We can also turn the device into a drought and rain intensity monitor with more programming. There will always be improvements to make and functions to add. Nonetheless, this advanced warning rain detector will aid in protecting the VIRT at the observatory. Next slide. Thank you to my mentors and funders. For more information, please contact us. That concludes my presentation. Thank you. Any questions?
Thank you very much, Nikar. We have some time for questions. Okay, so, well, I have a question then. Okay, so if these are less, if you can put this together for less than $100, how many would you need to get an idea of like the very tiny differences in precipitation across the island?
Okay, so I would say about at least you need to create about 5 to 8 of them. We live in St. Thomas, 32 square miles, and the range of this device is about 8 miles. So if you place it respectively around the island, it would be enough. Like we know the rain normally comes from the east end to the west. So you can place it that way. So you wouldn't really need to place a lot of devices in the border area, probably at least 1 or 2. And then the rest you have closer to the area. Like you have one in Frenchtown, because the weather could come from the south or the north, but normally it comes from the east and the south. So you could have one in Red Hook, one Mountaintop, Frenchtown, anywhere around the Eteman Observatory within our 8 miles of range. And that would be enough. So about 5 to 8 of the devices will be able to function and protect the observatory.
Okay, and how much difference do you think if you put one at the Edelman and you put one, say, maybe over by East Carrot Bay or West Carrot Bay, just above, where am I trying to describe? If you put one maybe down in one of the guts on the north side, what difference do you think you'd see between like elevation and even kind of further west positioning? Does that make sense?
Yeah, I understand what you're saying. Like if it was really far, but
not very far. Maybe not very far. Maybe just a couple of miles away, but a different elevation and a different part of the island.
Okay, yeah. So the antenna is a line of sight antenna, which means like directly, you don't really have to see the other one, but it has to be pointing. So all the devices will be pointing to the Eteman Observatory. So let's say if there's, well, we know it's the highest point one of the highest points in St. Thomas. So that it's kind of easier to get a line of sight, but there's small hills and let's say like buildings and houses and trees that can disrupt the communication.
Yeah.
That's a line of sight. So you have to put it in a strategically good place for it to communicate. Like, let's say it has a mountain in front of the device, then it would still work, but it wouldn't work as effectively as it wouldn't communicate fast enough as we need it to. So you may need to position it in a different place around the island and still be in a range.
Yeah.
But once it's still line of sight, then it will be able to work.
Okay. Okay. Would you expect to see a lot of interference with some of those mountains, maybe? I mean, you just kind of said that. You kind of answered that question. So
yeah,
thank you very much. Yeah, so that's very, very interesting. Especially that you can put them in for not very much money.
Yeah.
Okay, so thank you very much. Our next speaker is Anelia Ostry.
Good afternoon to all. My name is Anila Ostry. My mentor is Dr. Castillo Bernard, and today I will be presenting to you my research project on 1-year biological and chemical water quality assessments at the UVI Albert A. Sheen campus drinking fountains. Next slide, please. All life rely on water. Nonetheless, less than 1% is available as fresh water. It is critical to consume clean water, as ingesting contaminated water leads to many health problems and can also result in death. In 1974, federal passed the Safe Drinking Water Act because of the poor water quality that was endangering the public health. U.S. Environmental Protection Agency established over 90 contaminants, standards for over 90 contaminants. Next slide. Maximum contaminant level, also known as MCL, was established by Environmental Protection Agency, EPA, which indicates the highest level of contaminants accepted in drinking water. On the left of the chart are the contaminants which we tested this year or for 1 year period. Maximum contaminant level is in the middle, and on the right are the effects of these contaminants have on humans. That's excess, if it's taken in excess. For example, nitrate, the maximum contaminant level is 10 milligrams per liter, and some of the effects on humans if there is excess nitrate would be headache and skin irritation. Next slide. In 2019, Emerging Caribbean Scientists Program conducted a study where the objectives were to collect and test contaminants and to compare water quality between UVI drinking water and commercial drinking water. During summer 2019, 6 out of the 9 locations were tested. The yellow dots on the map represents the fountains that samples were gathered from. The red dots shows the fountains that are not working. The parameters tested were metals and non-metals. All contaminants, majority of students do not drink from the campus water fountains. However, it was determined that the parameters tested are the same in commercial water. That's the blue water they tested, and drinking fountains. However, the biological tests, they did not perform. Next slide. I was part of the class which conducted water quality assessments over a 1 year period. This year's goal is to analyze data trends and to include biological contaminants, that's total coliform, which was missing from last year's research. Residential Hall, Melvin's Evans Campus, EVC, and Northwest Wing, NWW, are the locations which we gathered samples from. To perform the water quality assessments, the hatch kit and the spectrometric meter were used. Next slide, please. On the chart, the blue graphs represents the Evans Center, green graphs represents Northwest Wing, and orange depicts the residential hall. The x-axis represents the semesters, which are summer, fall, and spring, while the y-axis represents the measurements in milligrams per liter. The following slides will have a similar format to this one. The MCL for chlorine is 4 milligrams per liter. The highest was found in the Evans Center in the summer semester. Chlorine maximum contaminant is 4 milligrams, and all of the samples we collected were below the MCL. Next slide. In this case, phosphorus had significant differences in one or more treatments in the Evans Center samples. It was highest in the summer. Fall semester showed the lowest results in the Evans Center. There was no comparison to MCL since phosphorus does not have a maximum contaminant level. Next slide, please. Results for nitrate showed that the spring semester had the highest level, with Evans Center being the highest and also exceeding the maximum contaminant level in spring semester. The maximum contaminant level is set at 10 milligrams per liter. Next slide. Results for copper showed that all the contaminants or samples collected were below the maximum contaminant level. Copper, however, had significant differences in the Evans Center. Next slide. Lead results showed no significant levels. The highest levels were found in the northwest wing in the fall semester. In the Evans Center and North Wing, the results were 0 during spring semesters. Next slide, please. Conclusion. Copper nitrate and phosphorus from the Evans Center showed significant difference. P-value was greater than 0.05. Arsenic and total coliform were absent. Nitrate was the only contaminant above the EPA standards in Evans Center location. Copper, lead, arsenic, all non-metals, and total coliform were all below EPA standards. Based on the results from the parameters tested, it is safe to conclude that the water at the Albert A. Sheen campus is safe for consumption. Next slide, please. Thanks, NSF, for funding. Special thanks to the faculty and managers of the Emerging Caribbean Scientists Program for selecting me to participate and do research in this summer program. Special thanks to my mentor, Dr. Castillo, College of Science and Mathematics for providing the materials for experiment, Joel Comerbach, Dazonte Maturin, and Shimika Stanley for their assistance in the lab. Thank you all for listening. I will now be entertaining questions.
Great job. Let's see. Why do you think there was so much variability in contaminant levels between terms and buildings?
Okay, I think we did not research that, but I think it's because of the location in which the water is coming out from.
Okay, what do you mean by that?
The water fountain, some of the water is distributed from a different company. So it shows different results.
Okay. Why do you think the nitrate levels were so high just in that one time in the springtime?
That one I cannot answer.
Okay.
Do not know.
Were the spring 2020 samples taken before or after we went remote?
They were taken after. All the experiments were done remotely, but I did the analysis after.
Okay, so I guess maybe the question relates to before or after there were people on campus. Do you think that would make a difference?
I don't think it would make a difference because the water is not contaminated between people.
Okay. What might be some other activities though that people do that might lead to a change? So what you're suggesting is that it doesn't matter when you took the water samples before or after we went home, because you don't think that there would be an influence.
Correct.
Activity on campus. Okay. Okay.
Yeah.
Any other questions? Okay, great job. We're going to move on to our next speaker. Hopefully. Our next speaker is Kiwani Smith.
Good afternoon, everyone. My name is Kiwani Smith. I'm a senior, majoring in physics. And with CGTC, my mentors, Dr. Gregory Guanel, Ms. Ariel Stoltz, and I, we decided to work on solar energy sustainability in the U.S. Virgin Islands. Next slide, please. Okay, so I'll give you a rundown of what I'll be talking about today. So the question, problem and solution, materials, procedure, temperature analysis and effect, my MATLAB, looking ahead, and thanks and questions. Next slide, please. So the question that was posed was, does the US Virgin Islands have the capacity to run on 100% solar energy? Next slide. So when compared to the US mainland, the US economy is 6 times more energy intensive than the US economy. Per capita, we use 7 times more energy than the US, and this makes the cost of energy 5 times greater than in the US. And looking at the fossil fuel emission, it's about 3 million metric tons worth, always coming from petroleum, not necessarily all from water, but probably a great amount. Next slide. So the solution. In 2010, former Governor DeYoung had implemented a plan to reduce petroleum use by 60% by the year 2025 using renewable energy, which includes biomass, solar, and wind energy. And because we focus on solar energy, I'd like to quickly give a brief rundown of what solar irradiation is. So solar radiation is just a big word for sunlight, and solar irradiation is just a measurement of this sunlight measured in kilowatt hours per meter squared per day. Next slide. So materials, it wasn't really much physical materials, it was more two basic items. So my laptop, which has the multiple different programs on it like ArcGIS, MATLAB, Microsoft Office, my review papers and the data, and my brain to help me process and retain this information and relay this information to you all. Next slide. So procedure, before I did any of the steps listed here, I read papers to gain some background knowledge on the subject. Then the first thing I did was took Excel data and plotted it into ArcGIS. So what I did here was I imported an Excel file and I put a hot and cold grid so that the lower insolation numbers, solar radiation numbers, are blue and higher numbers are red. And you can see that in the southeastern part of St. Croix and in the eastern part of St. Thomas on this day, June 20th, 2020, would have been the best areas for insolation on that day. Next, I want to do correlate temperature and solar panel power output. More on this coming in the next slide, and find a way to simplify this data. Don't worry about that. So working on a temperature analysis, the second bullet point I was talking about. So a sensitivity analysis just shows how much of an impact a specific variable has on a calculation. A common misconception people have about solar panels is that the more sun you have, the hotter it is, the more power you get, and that's not necessarily true, because solar photovoltaics is just exciting electrons in cells using the sunlight, not necessarily the heat. And talking about the heat, panel efficiency is taken from standard testing conditions, or STC, which is always 25 degrees Celsius. And this is measured in percent per degree Celsius and differs depending on the type of panel that you decide to use. This could include the two typical residential solar panel types, which is crystalline semiconductor and thin film solar panels. Next slide. So for a crystalline semiconductor, what I found is that temperature can greatly affect the power output of a solar panel. Well, Sharp brand, for example, a Sharp brand panel with the efficiency of negative 0.49% per degree Celsius could lose roughly 5% of power output when you just increase it by 10 degrees. But I ran into some difficulties coming up with a conclusive result because other factors could affect the temperature of the panel, including panel spacing and the wind, the amount of wind that's blowing underneath the panels. Next slide. So MATLAB, welcome to the fun of coding. This was the first time in the 21 years that I've been on this earth that I've ever had to code, and this was definitely not the easiest thing to do. So with MATLAB, what we tried to do was take the Excel spreadsheet data that we had and find a way to come up with a code that would average data in bigger chunks, you could say, because the data that we got from the Puerto Rico Ag Water Management website was basically days, measured in days. So we wanted bigger chunks like months and different seasons and so on and so forth, so we could get more conclusive data for a certain time period. So we came up with two different codes. The one in the laptop is the one that I came up with, and some modifications were made by Ms. Stoltz, and this does work. I just need to find a way to insert the equation relating the solar irradiation and the electricity from the panels together so that we could put this into the ArcGIS software so that not only we could find out where an island would be best, but I have a building map and that would basically tell us where on island, what time in the year, what time in the day. Well, not necessarily in the day, but you could look that up and find it, usually around noon. And the second code that I have underneath the information, that was kind of the long-winded way. I couldn't necessarily get the one in the laptop to work as well as I wanted it to. So what I did was I asked Dr. Guanel, and he came up with this way. It's kind of a brute force method. It's a longer way because I have to input the files manually. But once I find a way to not do that anymore, this will probably be the way that I will use in the future. Next slide. So looking ahead, what I'm planning to do is continue working on the ArcGIS that I just mentioned, continue using the code to input the different clusters of data into ArcGIS. I would like to network with more people, probably with Orange Wave for some temperature data on the island. I've contacted the BMV, IRB, Government of the Virgin Islands, Economic Research Bureau, all of them to help me work on the second part of this project, which is more on the transportation aspect of this. How much electric cars could be sustained with the amount of power that we would get from these solar panels. And lastly, I'll apply all this information. Next slide. Acknowledgements, I'd like to thank these people. I'd like to thank my mentors, the coordinators of this program, the grants managers, sponsors, and everyone, and the people who I've read papers from for doing prior research that would allow me to help me finish this research. Next slide. Thank you for listening. And I will now listen to any questions that anyone has for me. Thank you again.
Great, thank you very much. I'm excited about the idea of reducing our energy, emissions, our carbon emissions. I had a question. You identified that you mapped the solar radiation. Where did you get that data from?
The data was taken from the Puerto Rico Agricultural Water Management website. So okay. They have the data for every day until about 2009 to about June this year, I think. So that's where I have the data from.
Okay. I have a question from the audience. The question is, what about coding is difficult? Is it understanding it or performing it?
Well, it's kind of a mix of both. Well, for me, it's kind of a mix of both because I kind of get the gist of what the different things in the software mean and what they do. But whenever there's an error, it's kind of difficult for me to find a way to fix the error. So I usually have to look online, and then that doesn't necessarily give me a direct answer. So I'm always looking for ways to correct my work. And that's more or less what's difficult.
Okay. Yeah, so with the coding, you either get the outcome or you don't, right? And then if you don't get it, you have to go through and figure out where you went wrong. Is that right?
Mm-hmm.
Yeah.
Yeah.
While there's more to do, what is your gut feeling as to whether or not the USVI could meet the 2025 goal?
Let's see. Well, seeing the research that I've looking at the research that I've seen, I mean, we have done something in terms of solar energy. We built solar farms, one in Duno in St. Thomas and one in Spanish Town in St. Croix. But those were damaged by the hurricane, and I think a company bought the rights to them or something like that, so that they could fix them, so that WACO could buy power from them again. That would probably help somewhat. I think they're building some wind turbines somewhere in the eastern part of St. Thomas. and those would help also. So they could reach this if they continue going at this pace. It might be either close to it or they might reach it, but yeah, that's how I feel
Yeah.
about it. It's possible.
I'm sure there's a lot more to think about, and a lot of other things that we could do. We'd love to see solar advances. We have to move on to our next presenter. Let me see.
Answer the questions in the chat.
Yeah, answer the questions in the chat. Our next speaker is Dejante Maturin Fair. I think I butchered your middle last name. Let's see, let's go. Whoa, okay.
The title of my project is Kale Leaf Growth and Water Content. My mentor was Dr. Thomas Zimmerman. So, you may not know much about kale specifically and wonder, why did we choose to work with it? Well, kale is a superfood high in vitamins and minerals, and it is known to be relatively fast growing. You can go from seed to full-length leaf in under 60 days. Now, if you're a farmer, you want to know which varieties of kale are the best to grow for your area. In that 2 months, you want to maximize speed. So, previously, 8 kale varieties were evaluated in Kentucky for production. We decided we would do something similar here by determining the rate of the variety's leaf growth and when specifically they were ready to harvest. We also set out to determine the percent water content of the kale varieties. One of the reasons being, if they store well, they can be used as a food source during hurricanes. Our null hypotheses were that all kale varieties grow at the same rate, and that each variety has the same percent water content. When determining leaf growth, we began with seeds obtained from a commercial vegetable catalog and started them in the UVI greenhouse. They were transplanted into the field in a completely randomized block design with 15 plants per variety per block. There was half a meter between plants and 1.8 meters between rows. We used drip irrigation to water the field and applied organic fertilizers as necessary. 3 plants were selected of 15 plants per variety and block that had a 2 centimeter long leaf. We chose 2 centimeters long because any smaller was hard to get to and extremely fragile. The leaves were measured thrice a week and entered into an Excel spreadsheet. The data was. We later determined averages, plotted them in graphs, and ran an ANOVA on final lengths. When determining leaf water content, 10 kale leaves were harvested from 15 kale varieties and organized into 2 sets. 1 set of 5 leaves weighed individually, and 1 set of 5 leaves weighed together. The leaves were then weighed with and without midrib and then dried at 125 degrees for 48 hours. Once the drying was done, we recorded the dry leaf weight and determined the average leaf weight. All of this data was entered into Excel to make the groups you'll see in a second, and we used a t-test to compare each variety with midrib to without midrib. For our results, on leaf growth we found that the change in daily growth is logarithmic for the first week, as you can see by the graph. So over here, for our y-axis, we have length in centimeters from 0 to 7 centimeters, and our x-axis is the days after planting. We planted them on the 8th day, continued till the 32nd day, or the 31st. We also found kale development is a linear curve with 3 distinct groups, which is on this graph down here, where the length again is the y-axis from 2 to 22 centimeters, and the same x-axis as days. These 2 groups are the dinosaur variety, which is a variety which has large, deep green leaves, and they're very flat. In the middle here we have the green curly, which is like dinosaur, but lighter, smaller and curly leaves. And the purple curly, which is essentially the purple version of the green curly. It also had the smallest leaves. Then up here with the dinosaur was the red Russian variety, which had large leaves similar to the dinosaur, but it attracted a lot of insects. Should note that these are the abbreviations for the varieties. In our results for water content, we found that the kale leaf midribs significantly increase the fresh weight of the leaves. So the weight with the midrib is over here. The weight without the midrib is the orange or right. And the weight is from 0 grams to 20 grams for your y-axis. And again, the x-axis is the varieties. We believe that they increase the weight because they're quite dense and fibrous. Midribs tend to be. The kale leaf dry weight mirrored the fresh weight trend, except that the maximum was dropped from 20 grams to 2 grams, so a lot of their weight is water weight. There was also no significant difference between the percentage water content with or without midrib. And when grouped by type over here, the percentage water content trended higher with the midrib removed. So as you can see, there are lighter colors to the right, which are the midrib removed, and they have a higher percent water content than group on the left, which is with midrib. There's only one group over here for Red Russian because unfortunately their fragility only allowed us to get enough accurate data without the midrib. We found that all of our kale varieties have water percentages between 80 and 90% at roughly 85%. As I said earlier, the midrib does contribute a fair amount of weight, so when it was removed, the water percentage was generally higher. Now for our conclusions. We rejected the hypothesis that all kale varieties grow at the same rate, and we did not reject the hypothesis that our kale varieties have the same water content. We discovered 4 distinct kale types based on leaf characteristics and growth patterns. We now know that a 2-centimeter kale leaf is harvest size in 2 weeks, and dinosaur kale is the best type of kale to cultivate. And lastly, a significant portion of kale's fresh weight comes from water, making it good for dry storage and useful, especially during the hurricane season. Me acknowledging the many people who worked with me and my funding organizations such as the NIH, because I'm a RISE scholar, UVI, which allowed us to use their fields, UVI Biotechnology Center, which my mentor is from and funds him, USDA, which funded our field. Any questions?
Okay, so we have time for some questions.
Good afternoon. Can you guys hear me?
Yes.
Okay, I see Dr. Pearson asked, how do you define best in terms of type of kale to grow? We define best, the dinosaur type, as best because it has very large leaves, and you want large leaves when it comes to kale because that's what you eat. You don't want it to be attractive to insects. We want it to be resistant to them, which dinosaur is very resistant. And overall, we want it to do good on St. Croix. And dinosaur is resistant to our tough soil, the sun. We have it going in the field wild just right now, and the grass has overtaken many of the other varieties, but many of the dinosaur varieties are just there, standing bold and proud, as if a challenge is being thrown down. And I see, let's see, Dr. Amy Dreves, what variety do farmers currently grow? That, I don't know specifically, but I think that they grow whatever variety they choose from catalogs, because there's no set, from what I know, I should say, there's no set, we grow this variety, because this is one of the first studies that's been done on kale and St. Croix. So they grow whatever variety they can get, because everybody thinks it's kale and it's equally good to grow. So they just grow whatever they can afford to get. Any other questions? I measured like 135 plants per day, so there's a lot I can answer about them.
We have a question, is the dinosaur variety easy to get by seed?
Easy to get by seed. You mean like, are the seeds cheap? I'm gonna assume that was your question. And let's see. We kept a catalog of the prices of the seeds that we bought, but off the top of my head, I cannot remember that. I think I have your email, and if not, I'll put mine in the chat, or it should be in the abstract. So I'll find that and get that to you later.
Okay, I think the question was more about how easy is it to, to find these seeds, to buy them?
Oh, they're in
Are they readily available?
Yeah, they're in commercial catalogs. You can find them in, if they have pictures, you can see the dinosaur varieties. Otherwise, we have a list of the ones we use. We can give those to you so you can see if any catalogs have those names. But they're relatively easy to find.
Okay. Any other questions for Dejante?
If you want to. Okay.
So Dejante was our last speaker of this session. And so we can return to some of the other speakers. I'm not sure how many of them are still here, but I see at least one that's still here, to ask if there's any other questions from any of the speakers, or if anybody has some thoughts about some of the presentations that we heard and saw today. Any comments from anyone about what you learned today? All the presentations were great, very interesting. They were great. This is the first time that we've done this. I'm very excited because we didn't know how this would work. And it worked out okay. There were a couple of glitches, but the presentations were great. Presenters, I just want to say that the students, this is the first time that our students have worked remotely away from their mentors, and they all did just such an amazing job, in these challenging circumstances where they couldn't, drop into someone's office. Amy Dreve says, I'm proud of all the students. What an experience. Me too. Any other comments?
I guess I have a comment saying,
yes,
good job to all of us, because we did work. We kept with this a lot. It was not easy doing the research. It took hours sometimes. Other times it was relatively easy to set something and walk away. Other times it was being active for hours. So congratulations to everybody for making it through. Yeah, good job.
Yeah, good job. Congratulations to everybody for making it through. Yeah, it was not easy. Any other comments?
Yeah, just want to say thanks to the staff for the opportunity.
Yeah, you're very welcome. Okay, well, if there are no more questions or comments, I'm going to go ahead and close this session. I want to thank all the students for all of the hard work that they put into their research this summer and for working with their mentors. I want to thank the mentors for being flexible and creative in allowing our students to participate in this changed format. And thanks to the funding, the NSF, the MARC and RISE and SURE projects, and the College of Science and Math and private donors. Thank you very much for participating in our first ever virtual research symposium, and we hopefully will see you rather than ECU at the research symposium in the fall. So thanks for coming. Goodbye.
Goodbye.